Under our techniques, you have algebra. So if you integrate a constant k, you get back kx plus c. If you integrate x power of n, you just increase the power by 1, divide by the new power. If you have ax plus b whole thing power n, you just the same thing, increase the power by 1, divide by the new power. Although you have to divide by the derivative inside the function. And these two functions only apply when n is not minus 1. So when n is minus 1, you get 1 over x and 1 over ax plus b, right? And therefore you get the ln function, ln x and ln ax plus b, though for ax plus b, it will also divide by the derivative of the function. If fx is purely algebraic, so let's say we want to integrate fx equal to dx, you just need to solve it term by term. So each algebraic term, you integrate it independently. But, if you need to, expand first. Under exponentials, if we were to integrate e to the power ax plus b, you get by the same e power ax plus b, but we must divide by the derivative inside the power. Under trigo, we have the three trigonometries, right? So we have sine, cosine, tangent. So if you look at the derivatives, which are sine ax plus b, cosine ax plus b, and secant square ax plus b. For integrating sine ax plus b, you get back minus cosine ax plus b, divided by the derivative inside. Same thing for cosine, just that it's now sine. Same thing for secant square, just that it's now tangent. And don't forget to divide by the derivative inside. Next up in our application, we have definite integrals. Basically, now we have limits in our integration. So let's say from a to b. So how do we apply this is simply, we let integrating fx be gx plus c. Basically, when we apply the limits, it's simply just square bracket gx, ba, don't need the constant c, and then apply the limits to give us gb minus ga. To find area between the curve and the axis, so let's say we have this cubic graph, right? And we have positive area a and negative area b, because negative area b is below the x-axis, and b is bound between a and b, a is bound between x equals to b to x equals to c. Therefore, to find area of a is simply integrating from b to c. Area of b, though, because negative, must have a negative sign, integrating a to b. We can also apply the negative sign to give us integrating b to a without the negative sign. If area of c, right, you notice is between the curve and the y-axis, we must find a function in terms of y, which is basically f inverse y, therefore integrating d to e.